In this demonstration, we will create an exhaustive IP and insert it into the RTL code of an existing design. For this example, we will use a board from the Dini Group. The target device is an Arria 10 FPGA from Intel. We start Exhaustive dashboard for Intel and create a new project. We select RTL Insertion mode and specify the location for the project. Now we need to set up Exhaustive IP. The first step is all about defining the link configuration. That is, where and how the Exhaustive IP is connected to the exhaustive probe. We first need to specify the target FPGA. Then we have to specify the bank and the pin locations of the transceivers that we use for connecting the exhaustive IP to the probe. The FPGA transceivers have to receive a reference clock to generate traffic. On our board, this clock signal is connected to pin M28 of the FPGA. The frequency of this clock must be entered as well. Finally, we need to select the line rate of the transceivers and the connector type. The link configuration of exhaustive IP is now complete. The second step of exhaustive IP configuration is about setting up capture units, that is, the logic for sampling data from inside the FPGA. On the left, we can see the list of the capture units and the multiplexed data groups connected to them. Up to 16 such capture units can be defined. Each of them has its own settings. In this example, we have defined two capture units. The first one is called pattern, has got 3 data groups and is 16 bits wide. The second capture unit is called video, has got 2 data groups and is 46 bits wide. Once this IP will be generated, we will have to add it to the target design and connect its I/O ports to the nodes we want to observe. The exhaustive IP is now ready for synthesis. For that purpose, we'll call the FPGA vendor tool. In this case, we need to specify the path to Quartus. The exhaustive IP top-level entity name can also be chosen. The files that result from the synthesis of exhaustive IP will be stored into this directory. The process of generating exhaustive IP is started with one single button. It will go through these steps. The exhaustive IP is now generated. Here is the set of files that were generated. We have the synthesized exhaustive IP in QXP netlist format. It would be a diff for Xilinx FPGA. We have two constraints files, one for the transceiver spinout and one for the timing constraints of exhaustive IP. We also have specific files for instantiating the transceivers, QSys in this case. For VHDL, we also generate a wrapper entity for exhaustive IP and a package with some types. Finally, we provide two templates, one for VHDL and one for Verilog, to help insert exhaustive IP in the RTL code. We have opened the target design in the FPGA vendor tool. The process of inserting exhaustive IP in RTL mode consists in adding it, like any other design IP, to the source code. We first locate the level at which we want to insert exhaustive IP and update the corresponding source file. We use VHDL. We need to add the code provided in the VHDL instantiation template, that is the file with VHO extension. Then we need to connect the signals that we want to observe from the source code. These signals have to be connected to the inputs of exhaustive IP. Finally, we need to add the modified source code and the exhaustive IP source files, including the generated constraint files, to the Quartus project. Please pay attention to the list order. After this, all we need to do is start the synthesis and implementation of the instrumented design. This process generates a binary file that can be used for programming the FPGA. The FPGA is then instrumented and ready for use with the exhaustive probe. This concludes this demonstration. Thank you for watching. Bye-bye now.